one thing you can think about is how many types of players there are. Okay, we know there's player 1 and 2, but there could be a few types, right? And it depends on the information that they have, okay, or information set. Okay, and player 1 actually have 3 information sets. Okay, the first information set for player 1 is this. Okay, player 1 has this information set. Player 1 knows that it is state A. If player 1 has this information set, player 1 knows that it's either B or C with probability 3/4 and 1/4. If player 1 has this information set, then player 1 knows that it's state D for sure. Now what about player 2? How many information sets does player 2? Player 2 has 2 information sets here, right? Player 2 either thinks that it's A or D with probability 3/4, 1/4, or that is C or D with probability 3/4 and 1/4. Okay, so given your information set, okay, you can form some beliefs. Okay, now for example, if the true state of reality is state A, what are the information sets that player 1 and 2 will have here? Player 1 will have this information set. That means if the true state is state A, player 1 knows that it is state A. But for player 2's information set is this one, which means player 2, okay, if the true state is state A, player 2 will think that it's A 3/4 of the time and B 1/4 of the time. Okay, now take another example. If the true state is state C, if the true state is state C, what is player 1's information? Player 1's information will be this. Okay, player 1 will think that it's B 3/4 of the time and C 1/4 of the time. Okay. Now if the true state for player 2 will think that it's C 3/4 of the time and D 1/4 of the time. Okay, so if the true state is state C, both players are uncertain. Now given your information set, so for each information set you should have one set of action. Okay, for example, if I'm player 1 with this information set, I have an action that I will associate with this information set versus player 1 with this information set and player 1 with this information set. Okay, with different information set you may have different actions given that information set. Okay, so let's look at this question. So this is an infection question, right? And in state A, okay, if the true state is state A, what will player 1 do? Player 1 knows that it's state A for sure, right? So what is player 1's action here? 3 is better than 2, 1 is better than 0, so player 1 will always choose R if the true state is state A. So therefore, okay, we know that, okay, this is for certain. We know that if player 1 knows that it's state A, player 1 will definitely choose R. Now, what will player 2 choose then if its true state is state A? If the true state is state A, player 2 is in a state of uncertainty. Player 2 will think it's either A or B. Okay, now player 2 need to form some beliefs about player 1 then, right, if I have some uncertainty. Okay, what can I form beliefs about? I can either believe that player 1 will always choose L here and L here, R here, R here, L here, R here, and R here, L here. Right, there are 4 sets of beliefs given the 2 actions. Right, but I know in state, so this diagram is clear to everyone. So everyone knows this diagram, which means what is true? Is the front people sign? So which means what is true here? Player 2 will always believe that if the state is A, player 1 will choose R. Right? Because I know that if the state is A, player 1 knows that it's A and player 1 will choose R. So I'll believe, so my belief will then eliminate L, L and LR. I will not believe that player 1 will choose L if the state is A. Okay, so I only believe R, R and RL could be possible. Okay, so therefore player 2 will form these 2 beliefs, RL and RR. Okay. Now if RL is the truth, is the action of player 1, then the expected payoff if player 2 choose L is the following. Okay, so let's look at the diagram. Okay, so we assume that player 1 will play RL, which means player 1 will play R here and L here. Okay. Now if player 2 choose L, okay, then there's 3/4 chance that he'll get 0, and there's 1/4 chance that he will get 2. Okay, and that will give us 1/2 as the expected pair. Okay, if I choose R instead, there will be 3/4 chance that I'll get 1 and 1/4 chance that I'll get 0, which will give us 3/4 instead. Okay, so comparing the two, the expected value of choosing R is better than choosing L. Okay, so I'll choose R if I believe that player 1 will play RL. Now what if I believe that player 1 will play RR? Okay, again, we can calculate the expected payoff. If I choose L in this scenario, I will get 0. Okay, and if I choose R, I'll get 1. So again, I will prefer R over L, which means player 2 will prefer the action R. Okay, so given my beliefs are RL or RR, I will prefer R over L as player 2. So which means this player 2 with this information set will prefer R over L. Okay, so since I prefer R over L, now let's move the true state to state B. The true state is state B. Player 1 will be uncertain whether it's B or C. Player 2 will be this player 2 who is uncertain between A and B. And we already know what this player 2 will do, right? We know this player 2 will prefer R. Okay, therefore player 1's belief under state B should be R, L, and RR as well. Because player 1 knows that player 2, if there is state B, will choose R. So the same thing actually applies. So in state B, player 1 is now the one who is uncertain, but he knows that player 2 will always play R in state B, so his belief is RL or RR. Okay, so then we have the same expected payoffs, and we find that R is preferred over L. Okay, and we'll always choose R. Okay, going back to the diagram, it means that this player 1, okay, this player 1 will actually prefer to play R over L. Okay, then let's move the state to state C. If the true state is state C, we know that this player 1 will choose R. Okay, what about this player 2? This player 2 will believe that in state C, player 1 will choose R. Okay. So my beliefs, player 2's beliefs here will be R, R, and RL as well. Okay, so again we get the same conclusion. Player 2 will then prefer to play R, R, okay, R here and R here. Okay, so then finally moving on to state D. In state D, player 1 is certain, player 2 is uncertain. But what does player 1 know about player 2? We know that this player 2 always prefer to play R. Okay, and since this player 2 always prefer to play R, player 1, if he choose L, will get 0, and choose R will get 1. So player 1 here, although he knows for sure it is state D, he has to choose R, because player 2 here will prefer to choose R. Okay, so why does state A affect the outcome? So if all these states are states of certainty, that means if it's state B, everyone knows it's state B, then the inertial equilibrium will be LL or RR, okay, for states B, C, and D. Okay, however, because of state A, in state A, if everyone knows that state A, the equilibrium will definitely be RR. Okay, however, because of the uncertainty, this infects over to state B, C, and D. Okay, and all the equilibriums become only RR. Okay. So what is the Bayesian-Nash equilibrium? Okay, so we have to define it in terms of the types of players. So type 1A, type 2, so type 1A, 1B, and 1C. Right here, because it's an infection game, both type 1A, 1B, 1C always choose R. And both type 2A and 2B will also always choose R. Yeah, however, if it is not the infection game, then different types may choose different outcomes. For example, this player 1 and this player 1 may choose different actions. Okay, so as mentioned in the lecture yesterday, what will be tested is the for no duopoly, but you need to know how to draw these type of diagrams, and you need to know what this kind of rectangle means. Okay, so these rectangles are all information sets. Okay? They represent the information that a player has. Okay, let's look at the next question, which is the chronoduopoly question. Right? Anyone wants to do this? Okay. So the chronoduopoly question, here we have demand function is 200 minus 2 times Q1 plus Q2. The cost of firm 1 is 20. Firm 2 could either have high cost, which is equal to 40, or low cost, which is equals to L. Firm 1 believes that firm 2's costs are high with probability P and low with probability 1 minus P. Okay, firm 2 knows its true cost. Okay, so here, by reading the question, first of all, we should determine how many types of each firm there are. Okay. So for firm 2, how many types of firm 2 there are? Firm 2 knows true cost, and true cost can either be high or low. So there are two types of firm 2. Okay, one that knows that it's high cost, and one that knows that it is low cost. Now what about firm 1? How many types of firm 1 are there? Right, firm 1 only has one type of information, which is either it's P or 1 minus P. Okay, so firm 1 actually have only one type of information. There's no alternative information. So there's only one type of firm 1. Okay, and it's the type of firm 1 who is uncertain whether it's low cost or high cost. Okay, so let's draw the diagram, find the best response functions, and do some analysis. Okay, so this will be the diagram. Okay, so this great squares are the states that a state of being. So in this question, there can only be two states, which is the high state or the low state. Okay, whether cost is high or low. If firm 2 knows that its cost is high, it knows for certain. So this represents firm 2's information set that is high, and this represents firm 2's information set that is low. Okay, firm 1's information set is just this whole thing, because firm 1 has no idea whether it's high or low. But it knows the P. It knows what is the probability that is high and what's the probability that is low. Okay, so we determine, using this diagram, we can determine that there are three different types of players. Okay, so there should be three reaction functions. Okay, so we will set up three types of profit functions and find the three reaction functions. Okay, there's only one type of firm 1, and the type of firm 1 is uncertain whether it's high or low. So it's 1 minus P chance that it's low and 1 P chance that it's high. Okay, so if you think back to question 1, given a particular type, okay, or your information set, you should only have one action. Okay, and what's the action of firm 1 is Q1. Right, Q1 is my choice, firm 1's choice. Okay, so within the whole profit function, Q1 is consistent. Okay, it doesn't change from this scenario to this scenario. Okay, it's always Q1. That means I always only make one choice of Q1. Okay, because I don't know whether it's high or low. Right, I can only make one choice and wait and see what happens. Okay, so Q1 is always the same. 20 is the cost of firm 1 and it's always the same. Okay, the change here between this side and this side is the QL and QH. Okay, so there's 1 minus P chance I think that the cost is low. So if the costs are truly low, firm 2 will produce QL. Okay, and there's P chance that the costs are high, and if costs are truly high, firm 2 will produce QH. Okay, so writing this out, we take derivative, set it to 0, we can get the reaction function of firm 1. Okay, you notice this part is actually the expected value of quantity of firm 2. Okay, it's 1 minus P times QL plus P times QH. Okay, for the other two type of firms, for the low cost firm 2 knows that its cost is is low. Right? So low cost firm 2 will produce QL. It knows that its cost is L. Okay, and it will assume that firm 1 will produce Q1. Okay, which is so firm 1 will produce Q1. Okay, so taking this profit equation, we take derivative set to 0, we can find the reaction function of firm 2. low cost. Okay. Now for firm 2 with high cost, it's the same, except now firm 2 knows that its cost is 40 instead of L, and firm 2 will produce QH instead of QL. Right? Because we have different information set between these two situations, firm 2 should produce different quantity, okay, in these two situations. Okay, so you take derivative set to 0, you get the reaction function. Okay, then we just solve the three reaction functions simultaneously, where we have three equations, three unknowns. P and L are not unknown, they are just constants, right? So we can solve, and we can get Q1 star, QL star, QH. Okay, now part C asks you to analyze the effect of L, so let's look at the effect of L. Okay, for Q1 star, the effect of L, if L increase, Q1 star will increase. Okay. That means, what is L? L is my rival's cost, right? Because I'm firm 1. If my rival costs go up, I will produce more. Okay, this is consistent with the Kono model. If my rival's cost is higher than mine, I will produce more units than my rivals. Next, we look at QL star and QH star. If we look at this, and we look at these two equations, we find that the difference between QL star and QH star is only here at this part. Okay, 440 minus 3L or 390. Okay, also notice that if L is equal to 40, this becomes 320. Okay, so what is 40? 40 is the high cost. Okay, that means if both high cost and low cost is 40, right, then by right QL and QH should be the same. Okay, QL and QH should be the same. Right, because if CH and CL are both 40, there is no uncertainty at all. Right, and we should get the same result. Okay, but since L should be lower than 40, right, because 40 is the high cost, then this is always larger than this, which means QL is always larger than QH. Okay, so this is also intuitive from the Kono model. If my costs are lower, I should choose to produce more than if my costs are higher. Okay, so that's the analysis for us. Okay, which is shown. Okay, so next we substitute in L equals to 20 and P equals to half, and we can get these numbers. Okay, so Q1 star will be 31.6, QL will be 29, QH will be 24. Okay, we take the expected profit of firm 1. Okay, it will be $2,005. Okay, this expected profit is half a chance that is high cost, half a chance that is low cost. Okay. Now, if the true state is low cost, then firm 1 will be able to get $1,847, and firm 2 will be able to get $1,701. If the true state is high cost, firm 1 will be able to get 2,163, and firm 2 will be able to get 1,168. Okay, so L is assumed to be 20 here. That means if the state is L, then both firms actually have the same cost. Okay, both firms have the same cost. If the state is high, then firm 1 have a cost advantage. Right, so under the high state, firm 1 has a cost advantage. Firm 1 will make more profits than firm 2. But then something weird is happening here, right? Because if the true state is L, both firms actually have the same cost. Okay, but firm 1 will be able to earn more than firm 2. And that's because of the uncertainty. So let's look into this further by looking at the perfect information case. Let's assume that both firms have a cost of 20 and calculate what will happen if both firms know for certain that the cost are 20. Right, both firms knows for certain what we'll get is Q is 30 and profit is 1,008. Okay, so if compare back to the uncertainty result, in the uncertainty result, if the true cost is L, firm 2 will actually produce 29, firm 1 will produce 31. Okay, so firm 1 produces more than 30, whereas firm 2 produces less than 30. Okay, so how does that result? Because firm 1 is uncertain. Okay, firm 1 don't know if the cost is high or low. Right, if the cost is low, I will produce less. If the cost is high, I will produce more. Okay, and because I'm uncertain, I'll compromise with something in between. Okay, therefore I'll produce something more than 30. Now because of this uncertainty and I produce something more than 30, firm 2 will have to compromise as well. Okay, firm 2 has to readjust their profit maximizing point because if they still insist on producing 30 here, their profits will not be optimal. They have to lower their quantity produced as well. Okay, now because of this compromise, then firm 2 end up earning less than 1,008 and firm 1 earns more than 1,008. Okay, and firm 1 will become better. Okay, now if we compare the two, okay, if we transfer the $47.20 over here, this will be still less than 1,008. Okay, which means the uncertainty actually causes inefficiency, right? Because if there's perfect information, both firms will earn profits of 1,008. Okay, so there will be inefficiency as a result as well. Okay, so if you are firm 2 and your costs are low, would you choose to let firm 1 know or not? You will, right? If you let firm 1 know, you'll get 1,008. If you don't, you'll get 1,007. Now I'll leave the other part for you to find out. If your costs are high, will you choose to let firm 1 know? Okay, what you need to do is to calculate the perfect information case with high costs and compare, okay, and to see would you prefer to let firm 1 know. Okay, so you can find that out on your own. Okay, so more complex. Okay, it will, and it's complex because there's uncertainty on firm 2's side as well. Okay, so the next question we have demand for is 120 minus Q1 plus Q2. Firm 1's cost is 30, firm 2's cost is either high, which will be 30, or low, which will be 20. Okay, so this is different from question 2. In question 2, firm 2 always have a cost disadvantage if its cost is high. Right? If its cost is high, it will be 40 compared to firm 1's cost of 20. Okay, whereas in question 3, firm 2, if its cost is high, it is equivalent to firm 1. So firm 2 will never have a cost disadvantage in this question. Okay, whereas firm 1 may have cost disadvantage over firm 2. Okay, firm 2 knows its true cost, and firm 1 knows the true cost of firm 2 with probability. Okay, so how many types of firm 2 are there in this question? Firm 2 knows true cost, so there's 2 types of firm 2. It knows either its cost is high or its cost is low. Okay, so there are 2 states for cost, right? It can be high or low. Now there can also be 2 states for firm 1's knowledge. Okay, one state is firm 1 knows the true cost. Okay, and the other state is firm 1 does not know the true cost. Okay, so how many types of firm 1 are there? Okay, there's the type of firm 1 that does not know the true cost, so that's one type. Now, there's another type of firm 1 that knows the true cost. But if firm 1 knows the true cost, there's actually 2 types of firm 1 that knows the true cost. Okay, one type that knows that it's high, one type that knows that it's low. Right? So let's look at the diagram. Right, so remember I mentioned there's 2 states that cost can be high or low, and there's 2 states that of firm 1's knowledge is either don't know or know. Right, so we denote don't know with 0 and know with 1. Okay, so the combination of these 2 will give us 4 possible states of reality, which is L0, L1, which is the cost is low, L0 is firm 1 doesn't know that it's low, and L1 is firm 1 knows that it's low for sure. Okay, and H0, H1, which the true cost is high. H0 is firm 1 doesn't know. H1 is firm 1 knows for sure. So if it's either L1 or H1, firm 1 knows for sure. So firm 1's information set is certainty. Okay, so firm 1 knows for sure that it's L1, and firm 1 knows for sure that it's H1. Okay, if the state is 0, then firm 1 is uncertain. Okay, firm 1 doesn't know whether it's high or low. Firm 1 only knows that it occurs with half chance each. Now for firm 2 knows that it has low cost and knows that it has high cost. So it either knows that it's this 2 state or it's this 2 state. Okay, but firm 2 actually will not be able to tell the difference between this and this. Okay, firm 2 only knows that it's L. I don't know whether it's 0 or 1. Okay. And they will know that it's H, they don't know whether it's 0 or 1. So this part occurs because of the fact that firm 1 may know the true cost. Okay, that's why we have this part. If firm 1 don't know the true cost, will never know the true cost, then this part will disappear, and we get the same diagram as question 2. Okay, if now because of the additional part that firm 1 may know the true cost, then we have this extra section here. Okay, so how many types of firms are there? There are 2 types of firm 2. And there are 3 types of firm. Okay, so 1, 2, 3. Okay, so therefore we should have 5 reaction functions. Okay, so in the exam you can do something similar. You can give them some notation to make your life easier. Okay, so we can notate firm 1 with F10, 1H1L. So firm 1 without any knowledge, firm 1 who knows that it's high, firm 1 who knows that it's low. Okay, and firm 2 with F2H, F2L. Firm 2 who knows that it's high, firm 2 who knows that it's low. Okay, so then, remember as I said, given your information set, you will have a specific action. Okay, so if my information set is 1, 0, firm 1 will have a specific action. Okay, and that action will be different from if my information set is 1H and if it's 1L. Okay, so therefore, for each of this type of firms, there should be a reaction function. Okay. So firm 1, 0 will maximize its profit. Now what is the profit of firm 1, 0? Firm 1, 0 is uncertain between the 2 states. So there's half a chance that cost is low and firm 2 will produce Q2L. And there's half a chance that cost is high and firm 2 will produce Q2. Okay, Q10 remains consistent throughout because the action that firm 10 will take can only be one action, and that's Q10. Okay, cost is 30, that's consistent because firm 1 only have one cost. Okay. So we take derivative, set it to 0, we can find the reaction function. Now firm 1H is firm 1 who knows for certain that it's high cost. So if you know for certain, then there's no uncertainty. Okay, firm 1H will produce Q1H. Okay, and since it knows that cost is high, it knows that firm 2 will produce Q2H. Okay, so take derivative set to 0, we get the reaction function for firm 1H. Next for firm 1L. Again, so firm 1L here knows that the cost is low, so it knows that firm 2 will produce Q2L. And it knows that there will be, its cost is Q1L. So we take derivative, set it to 0, we get the reaction function of firm 1L. Okay, so that's all for firm 1. So for firm 2, there's 2 types of firm 2, firm 2H and firm 2L. Now firm 2 is now always uncertain. Okay, no matter whether it's high or low. Okay, if it's high, firm 2 knows that its cost is high. Okay, so its cost is 30. 30 here. But it doesn't know, it knows that there's half a chance that firm 1 doesn't know and will produce Q10. And there's half a chance that firm 1 knows that the cost is high and will produce Q1H. Okay, so we take derivative again and then set to 0, we get Q2H, the reaction function of firm 2H. Okay, lastly we have firm 2L. Firm 2L is uncertain whether firm 1 knows or not. Right? If firm 1 doesn't know, firm 1 will produce Q10. If firm 1 knows, firm 1 will produce Q1L. Okay? So the cost here will be 20 because firm 2 knows that its cost is low and it will be 20. Okay, so again we take derivatives set to 0, we get the reaction function of firm 2L. Okay. So we have 5 reaction functions, we have 5 unknowns. Okay, we can solve them simultaneously. So some of you ask me whether you can use calculator, sure, go ahead. Okay. Just make sure you write down the equations properly first before you use calculator to solve. Okay. Because sometimes if you set it up wrongly in your calculator, you get the wrong answer. So make sure that it's correct. Okay, there's a danger with using the calculator now, that's what I'm trying to say, because if you choose the calculator function and your answer is wrong, you don't get marks for steps. Right, if you do it this way, you get marks for steps. Okay. So to solve simultaneously, we try to get rid of certain unknowns. So here I got rid of Q1H and Q1L. Okay, and then substitute back into Q10, I can solve for Q10, which is 28.33. Then I can solve for Q2L, Q2H, Q1L, Q1H. Okay, so that's how to solve five equation problem. Right, so depending on the state, so whenever you see this type of question, first of all you have to identify how many types of each firm there is. Okay, so it's definitely duopoly, so there's only firm 1 and firm 2. But you have to determine how many types of each firm there is. Okay, and given the number of types, there will be the same number of reaction functions. Okay, and then you just solve those reaction functions simultaneously. Okay, I think the solving part is not too hard. Okay, there's no squares or anything. You just substitute into each other. Right. But this part may be tedious and you may make careless mistakes. So be very careful here, and be very careful when doing this question. So as always read the question. Okay, the question. So don't assume that it's this format and the answer is this format. Right. So read the question and make sure what format it is. Right. What is the form of uncertainty? What is the form of difference between the two firms? Okay, and then write down those equations. Okay, or draw the diagram. Okay, any questions about the Kuno? Okay, now let's do the last question. Okay, the last question is public good and uncertainty. Right, so we have 100 individuals living in a small town. The public good costs $40 to implement. Gives each individual a value of V. The individual is the lowest valuation has valuation of 1. The next highest valuation is larger by 1, and the largest valuation is 100. Okay, so the probability that any individual's valuation is at least C is 100 minus C over 100. Will the public good be provided? Find the cost where the public good will not be provided. Okay, first of all, what's the probability that there's an individual with value larger than 40 is given here, 100 minus 40 over 100, which is 60%. Okay, so it's from 1 to 100, right? So anybody with value more than 40, will there be 60 people with value more than 40, so the chance that someone has a value larger than 40 is 60%. Okay, so to do this question, we just need to know whether the highest valuator will pay for the public good. Okay, because we only need one person to pay for the public good. Okay, so the highest valuator, if he chooses to pay for a public good, will get a value of 100 minus 40, okay, which is how much you have to pay. If he chooses not to pay, there will be a 60% chance that someone else will pay. And if someone else's pay, he will get 100. Okay, because he doesn't pay, you get the pure value of 100. So it turns out both are equal for the person with value 100. So this person with value 100 will always be willing to pay for the public good. Now, let's assume C is unknown. If C is unknown, that's part B. Actually, these two sides are equal. Okay, that means if my value is 100, these two sides will be equal for me. That means I'll always be willing to pay for the public good. If C is lesser than 100. Right, if C is greater than 100, then this side is negative, then I will not want to pay for the public good. So that's the answer. Okay, so that's it for the tutorials, and that's all for the whole course. Okay, if you are coming for consultations, we'll see you at the consultation. So if you are coming on those 3 days that I put down, you do not need to make any appointments. Okay, only if you are coming before those 3 days do you need to make appointments. If not, I'll see you during the exams. Okay, so for those of you who haven't filled the teaching feedback, I'll appreciate if you do that. Okay, other than that, that's it. I'll see you during the exams. Okay, attendance sheet is here if you haven't lost it.
Question 3B, so what's the Bayesian mesh equilibrium?
Is this set of solutions. This is the Bayesian.
Oh, these are the sets.
Okay, so these 5 answers.
Oh.